Hey guys, so we have our second to last lesson in this chapter, and so far we've solved two variable systems. So we've used substitution, we've used elimination, and what we're going to get into in this lesson is however many variables you're looking for, that's how many equations you're going to need to solve that system. So today's lesson is all about, we're trying to find three variables. We're trying to find x, y, and z, and if that's the case, then we need three equations. If you were looking for four variables, you would need four equations, and so on. It does create a little bit of work, and I'm sorry I can't be here today, but I'm going to have you guys try a couple of these before and pause the video before I go on after I show you the first couple and kind of our process. Now this first one I have set up in a way that is as easy as I can make it. And try to look at it and think about why this is as easy as I can make one of these types of problems. Like, what could you do right off the bat? And hopefully you notice this bottom equation, you can actually figure out what z is right from the get-go. You know, this first equation, there's three letters, that's not very helpful. And then there's 2, and then this one, we can find z is 2 right away. So right off the start, we know that z is 2. And then you look at the next equation, the second one, and notice how there's a y and a z in it. Well, we know that z is 2. Once you find z is 2, z is always 2 for this system. So that means we could put 2 where that z is right there, and we would have y plus 3 times 2 equals 5. And so we could figure out what y is right away. So 3 times 2 is 6, so subtract 6 from both sides. Y equals -1. Well, now that you know what y and z are, look at the very top equation. We need to find what x is. Well, we know y is -1. We know z is 2, so let's plug those numbers into that top equation. So x minus 2 times -1 plus 3 times 2 equals 9. So I'm just plugging in -1 and 2 into the top equation for y and z. And we got 2 plus 6, that's 8. So x plus 8 equals 9. X equals 1. Well, when you solve a normal system, you write an ordered pair. Well, these answers are what's called an ordered triple. So we're just going to write them like we normally do. We're just going to put it in alphabetical order. So we put 1, comma, -1, comma, 2. And remember what it means to solve a system. We just found what x, y, and z have to equal that would solve all three equations. Okay. Well, the next example isn't set up so easily where you could find one letter right off the bat. There is a typo on this one, so you do need to change one of these letters. This 5x down at the bottom should be a 5z. That should be a 5z. I screwed that up. Okay. So what I'm about to say is going to sound like a mouthful, kind of the process. You know how substitution, you have to get a letter by itself. Elimination, you try to get the same number in front of the x's or the y's with different signs and then add. Well, with 3x3 systems, you have your own kind of goal or process. So I'm going to say this a couple of times. Here's what I'm going to say. You need to pick a letter, okay? And you have, in this case, 8 letters to choose from. 3 on top, 2, 3. You need to pick a letter and use it to eliminate that same letter from the other two equations. Let me say that again. You're going to pick a letter. Typically, you're going to pick one that has a coefficient of 1 in front of it. So, like, when I say pick a letter, I look at all these. I'm going to pick that x right there. You'll see why. But I'm going to use this x to eliminate this x and this x from these two equations. Basically, you're going to be doing elimination 2 times to get rid of these two x's. And you'll see why that's going to be helpful. So right off the bat, let's go ahead and just look at this first equation and second equation. And if I wanted to do elimination and eliminate the x's, think about what I could do to eliminate these x's. Well, I could just add these two equations together right now. So let's see what happens if I add the first and second equation. So the x's are gone. I'm going to get positive 1y. I'm going to write this right over here. 3z plus 0 is still 3z. And it equals 9 minus 4 is 5. So I used that x to eliminate that x. And I was able to do so by just adding these two together. Now I like to say go back to the drawing board. You're done with that middle equation. Go back to this top x right here, and let's use this x to now eliminate this 2x. So think about what you would do with normal elimination if you were going to have this x eliminate this 2x. Well, you'd multiply this top equation by -2. So I'm going to multiply this top equation by -2 and write my new equation right below this one. So I'd have -2x, positive 4y, -6z equals -18. So I'm just distributing this -2 to the whole top equation. Now I'm going to add these two bottom equations together, and I'm trying to get rid of this 2x here. So when I add these, the x's are gone. That's the whole goal. Add these, and I get -y. I'm going to write this below that first equation I got. And then I have -z equals -1. So I want to stop and kind of go back to what we did right off the bat. I picked this x, and I used it to eliminate this x to create this equation. And then I used that x to eliminate the 2x to create this equation. Now notice what we have. The whole reason I did it, now we have a normal 2x2 system that we've been solving for a week and a half. We could solve this using substitution or elimination. We can find what y and z are using our normal methods now. So let's go ahead and solve this system like we know how to do. This one would probably be easiest for elimination because the y's will cancel right off the bat. So let's go ahead and add these two together. So 2z equals 4. So z equals 2. But I'm not done solving this system. Take 2 and plug it back in for z and find what y is. So y plus 3 times 2 is 6 equals 5. Y is -1. So now we just solved this 2x2 system. We know what y and z are, and as soon as you know what two of them are, you could plug them back into any of these up here and find out what x is. Now you go back to your original system and plug these numbers in. So I'll use maybe the second one here because there's no z term. So -x plus 3 times -1, so -3 equals -4. Then add 3 over. So -x equals -1. X is 1. So we have 1, -1, 2. Alright, so you pick a letter and use it to eliminate that letter from the other two equations. And the whole reason that's a good thing is because once you eliminate that letter 2 times, you create a new system with 2 equations that only have the other 2 letters in it. In this case, the y's and the z's. So I'm going to have you pause it. In all honesty, you only get better at these if you do them yourself and find the mistakes that you might make along the way. It doesn't do a lot of good just to have me show you how to do every single one of these. So I'm going to have you pause the video, and I want you guys to try example 3. Okay, just try it. So go ahead and pause it, try example 3, and when you're done, play it and see if you got it. Okay, so it's hard to show these because some of you might have used, this x to eliminate these x's. Some of you maybe used this y to eliminate these y's. Maybe you use this z to eliminate these 2 z's, and so it's hard to show all the ways that you could do it. So I'll tell you what I would probably do, but when you're watching me work, it might not help you see your work, but you might see if you got the right answer. So I'm going to use this z right here to eliminate this -3z and this -1z. And the reason I'm going to is because I can see right off the bat, if I add these two together, it's going to eliminate this. I don't need to multiply the top equation by anything to eliminate this one. So I kind of look ahead at what's going to make my life easier. So I'm going to use this z to eliminate this -3z and this -1z. I'll start here. I always like to just go in order. So I'm going to use this z to eliminate -3z. So I'm going to multiply the top equation by 3. And so I'm going to get 6x 12y plus 3z equals 3. Almost forgot to distribute it to the 1. And now I'm going to add this to that middle equation because those 3 z's are going to cancel. So I get 7x and then 10y. Z's are gone. 2 plus 3 is 5. You really have to stay focused while you're working through these. I was telling my one block the other day, these aren't type of problems where you can, start them and then talk to your neighbor and then come back, because then you forget where you are and it's really hard to find out where you are. That's a 5, by the way. That's a terrible 5. Okay, so now I go back to the drawing board, and I'm going to use this top z to eliminate this negative z. It's kind of like I'm done with that times 3. I did that to create this equation, and I'm done with it. Now I can add this top equation and bottom equation together. The z's will go away. So 3x plus 5y. And then 1 minus 1 is 0. So I have a new system just with 2 letters in it. I could solve like normal. I'll use elimination. So I'm going to multiply this bottom equation by negative 2 to get it to have negative 10. Negative 6x, negative 10y equals 0. So x equals 5. Plug 5 back in right here. So 35 plus 10y equals 5. So 10y equals negative 30. Y is negative 3. And then once you know what 2 of the letters are, plug them into any of these equations over here and find, I'm looking for z now. So maybe I'll use this bottom one because nice small numbers. So I have 5 minus 3 minus z equals negative 1. So 2 minus z equals negative 1. So negative z equals negative 3. Z is 3. So I would have 5, negative 3, 3. All right. You may want to try the next one. Like I said, you only get better from practicing these. So if you missed that one, you see why or what you did, maybe now try this one. You're going to have plenty of time for your assignment today anyway, so you might as well take the time and try it yourself first. So pause it, see how you do. Okay. So I'm going to take this x right here and use it to eliminate this 2x, and then use it to eliminate this x. So I'm going to first multiply the top equation by negative 2. So I get negative 2x, positive 6y, negative 2z equals negative 2. So that's what I get. Now I'm going to add that to the middle equation. So those x's are gone. I'm going to get 5y minus 4z equals 0. Now I go back to the drawing board. I'm going to use that top x now to eliminate this x right here. So I'm going to now multiply this top equation by negative 1. So I'm going to get negative x. I'm going to write it right next to this bottom equation. Negative x plus 3y minus z equals negative 1. And now I'm going to add these two together. X's are gone. 5y minus 4z equals negative 2. Well, that's interesting. Well, now let's solve this. So I'll multiply the top equation by negative 1. So I can add these equations together. And when I do, I get 0, because both the y's and the z's cancel, equals negative 2. Just like with normal 2x2 systems, you can still end up getting no solution versus infinitely many solutions. And so this would be a case where this system just has no solution. So hopefully you got that. All right, the very last one I'm going to set up because of time. My son's sick today, so I have to get out of here pretty quick and get home. So I'm going to set this one up and kind of explain it, and then I'll have you kind of solve it just like the other ones that we've done. So this one, it's page 429, number 78 in your book, and I think there's one like in your assignment, but I'll show you what it looks like here and what we're going to have to try to accomplish. So it says an object moving vertically is at the given height at the specified times. Find the position equation. And so if you remember the position equation, we have s is the height at some time, a is acceleration, t is time, v naught is the initial velocity, which with the thing was dropped or thrown or whatever, and then s naught is the initial height the thing was thrown from or dropped from. So that's the position equation. Then they give us a scenario. They say this thing, okay, it's pretend like it's a ball. You're going to throw a ball up in the air. And after 1 second, the ball is 32 feet up in the air. After 2 seconds, the ball is 32 feet up in the air. Well, think about, first of all, how is that possible? How could a ball be 32 feet in the air after 1 second and 2 seconds? Does it just levitate and float in the air at 32 feet for a whole second? Well, no, it's a parabola. So it's going up, and at 1 second, it's at 32 feet, and then it goes up, and then it comes down after 2 seconds at 32 feet off the ground again. So it's surpassing 32 feet. And then at 3 seconds, it hits the ground. Well, let's look at how we can set up a system to find the position equation. So these three, since we're looking for three things, we're trying to find A, V naught, and S naught. We're looking for those three things, which means we need three equations. And that's why they give us three scenarios to plug in for S and T. Like, they're basically giving us the information to create our system of equations. So let's plug in scenario 1. S is 32 when T is 1. So let's plug 32 in for S, and then 1 in for T. So 1 squared is just 1 here. So really the T's just are kind of gone. We put a 1 in place of them. So we have 1/2 A, because 1 squared is 1, so we don't even need to put it, plus 1 times V naught, so just V naught, plus S naught. So there's equation 1 from plugging in 32 for S and 1 for T. Then the next one, plug 32 in for S and 2 in for T. So now here's where you need to be a little more careful, because we would have 1/2 A, and then 2 squared would be 4. Then plug 2 in for T here, so 2 V naught. I'm just going to put the 2 in front, because that you always put numbers in front of the letters, plus S naught. There's our second equation from plugging in scenario 2. And then plug in the third scenario. So S is 0 when T is 3. So I'm going to get 1/2 times A times 9. Plus 3 V naught. Plus S naught. And then I would solve this just like I did the other ones. But before I do that, I'm going to go ahead and clean up these equations. I don't like fractions in equations, so anytime I get fractions with equations in them, or fractions with equations in them, equations with fractions in them, I like to clear them. So what I'm about to do, you don't have to do, but I think it helps throughout the problem. So I'm going to take this whole top equation and multiply everything by 2 to get rid of that 1/2. So I would have 64 equals A plus 2 V naught plus 2 S naught. Just multiply everything by 2, so the 1/2 goes away. The middle equation, there are no fractions, because when you multiply the 4 and the 1/2, you get a 2 right there. So you would just have 32 equals 2A, 2V naught, S naught. The last one, 9 times 1/2 is 9/2. So I'd probably multiply this whole bottom equation by 2. Again, what I just did is not necessary, but you have a new system with no fractions to worry about. And then you would just solve like normal here. So I would, you have choices, but I would probably use maybe this A to eliminate this 2A and this 9A. Could be easiest to use this S naught here to eliminate these, because these are the same. So if you just multiplied this by -2 right here, then it would, you could add it to this one and this one. So you just find ways to make your lives a little bit easier when you're solving these. But I'll put the answer so you guys can at least see what the answer is. It's going to look sloppy, but maybe pause it, work it out, and see if you got it. So here is what the answer should look like. I had worked this out previously. The work got really sloppy. This was kind of just for me to see, not really for other people. But so once you find A is -32, V naught's 48, S naught is 0, you're going to now plug those back into the position equation to begin with. So you plug those three numbers in to your position equation. It's kind of like y equals mx plus b, how you don't replace y and x in the end. Same idea. You're not going to replace s and t. So here's your final answer. And then I just multiplied 1/2 and -32 together to get -16. So you'll definitely get some practice. I would check your answers. If you have questions, shoot me an email. I'll be able to answer them today pretty quickly. So hopefully it goes well. Good luck.